Hey. So, right. So, what I've done now, first of all, I've actually changed the coding. Well, I've changed the method of burning it. So now what I've done is I've actually changed it so that we're actually using C++ and a makefile instead of using the Arduino environment, which is it means well more. Also, you need to add some extra code in here because it has an extra register to enable you to access the other 8 bits, the other 8 channels. Sorry, because this one has 16 channels for the ADC. The Uno, which is at Mega 325, 328 or whatever it is only 8 channels, of which 6 are only available. So we've got, as you can see, we've got 16. Oh, you might be able to. Oh, just say from there. There you go. 16. So it's A0 to A15, 16 channels, and now we can see all of them here. Obviously, let me let me chop that. So you can see there. Basically, we're using C++, not an Arduino environment. Just burning it using AVR. Now you can see the 16 channels. I can't do the graph without adding extra code to do it, because that's just part of the Arduino. I mean, I can code up something which makes it into a plot, a live plot, but right now I actually want to see the actual voltage readings. So this one is 0 and this one is like quite static and the rest of them are quite noisy. This is because this wire here is connected to the ground, so it's grounding it out. This one is connected to our little circuit here. Right, now you'll notice here that there are actually come on. You'll notice here that I've actually got 2 diodes, and the reason why is I think I have 50 volt diodes, but I just wanted to see what it's like if you actually put 2 and to see if it just adds the voltages up. Now I've got a 20 volt and a 30 volt. Right, now it's still got the same 10k. It's quite possible I might need to make that a bit lower, perhaps even a 1k. Yeah, because the voltage across here will never be above 5 volts, so perhaps a 1k might be better. Yeah, because we're talking about milliamps and milliwatts. The car takes kilowatts, so it's not like we're actually going to be affecting the range. And so we've got 2 in series here, so that's 30 plus 20, which is 50 volts, right? So the idea is to subtract 50 volts, right? And also I calculated that the voltage, so we've got 13 cells, and the maximum voltage is 4.2 volts. Above that, it's destruction territory, so you shouldn't go above that. It might do, you might get things going a bit higher for whatever reason, but that's the rated stuff. And so so if I equals, there you go, so that's 54.6. so the maximum voltage is 54.6. I mean, I can go 55 obviously on the scale, or even 60. I would probably make it go up to 60 just for safety's sake, because you might get some spikes. So yeah, right. So the maximum voltage that we're expecting is going to be 54.6. Now, currently, I've got 54.2, and the reason why I stopped there is because, as you can see on this geezer here, that's actually at 5 volts. Now, if I take it up to 54.3, you can see he's kind of locked in. That's the max. Okay, right. Now, as I take it down, you'll notice that's 54.2, and then I'm going down 54.1, 54 dead, and then that's 53 dead, 52 dead, 51 dead. I'm just going to tune it up until there you go, it's 2 volts. So that's 51.1. So So that's 51 dead, and then 50 dead. Yeah. Now I'll go down, and you can see now it's dropping. That's 49.3, 49.2, 49.1, 49.0, 48.9. Right, so 48.9 is 0. Yeah, and if I take it up to 49 volts, you can see it's kind of noisy around 0. 49.1 is showing a reading, and then, sorry, 49.2, there you're talking about something like 0.1 volts on the reading. You see? That's kind of locked it in, 48.9. And if I take it up to 50, what is it, 52.2? Yeah. 50, oh sorry, no it wasn't, that was the wrong one. That's 53 volts, 54 volts. There you go, you're locked in. See? That's 54.1, that's 54.2. Yeah? So what I'm going to do is take it to the mid-range of this, which means that it'll read 2.5. Let's put it down to 2. There you go. Which is 51.6. Right? And you can see that you got 2.5, and then the next digit is flicking around a bit. But it's reasonably stable. You know, if I was to show that on a meter and average it, it will probably say 2.5 volts. You know, and you wouldn't need much smoothing in the software or at all. Right. So yes, you can put them in series, the Zenas, and yes, it seems to give you a stable voltage output, which is off what we're after. We can always calibrate the software to say that when that says whatever 2.5 volts, that we know that the voltage is 51.6. You can always do that, and then just simply you know, with your data points, just plot the curve based on what the readouts are. Just do a beforehand sort of thing, right? The other thing you can do, in actual fact, of course, is when the car is actually being run, you can see what the maximum and minimum voltages that actually appear on the cell, and then you know, full empty. It doesn't matter what reads there, and it doesn't matter what that reads there. As long as this reading maps to a full cell and this reading maps to an empty cell, then you can then tell somebody how full or empty the cell is. That's all you're after, really, at the end of the day. You don't care about the voltage that much. You really want to know the charge level. Yeah. So it works, and the software works alongside it as well. The circuit that we're using is not actually, so I've got a BMS circuit here. Let me make it bigger and turn the torch off. Okay, so essentially we've got a kind of combination here. It's this kind of circuit here, this kind of circuit here, right, with a 10k here, but we've actually got two in there, 110 and 130 and 120. So that's actually the circuit that we've got. But it's actually at this end because we're faking that we've actually got the last one, the last voltage. And it was just to make sure that nothing kind of untoward happened when we started sticking 50 volts through it, and it seems calibrated. So now what I want to do is try and redo this circuit because it's wrong. Well, it's not, it's just incomplete. We've got the voltages here. Okay. And what I got here is potential dividers because we've got two arithmetic operations. We've got the subtraction, which in this case is 12, so we're subtracting 12 because the actual voltage range will be 12.8 to 17.6. Okay, and so we subtract 12 from that, which then gives us 0.8 volts to what would that be, 5.6, okay, or something. Is that right? Yeah, it's 5.6, right? But the range is too great now because it's 5.6, and so I put a potential divider in here to actually do a division. Yeah, so we're dividing it or multiplying it by a factor or whatever you want to call it. It's 250 there and 1k there. So that means that will be, I think, approximately 3/4. Something around 3/4. So the range there is 5.6. So 3/4 of that would take it to sort of like, I don't know, 4.5. So which means it brings it within the range, the voltage range, which I can, there you go, 0.8 to 4.48. You see? Now you have to do it like that because you're measuring this cell voltage here, but you're measuring it against the voltage of the previous cells, and these could be at any voltage, you see. So that's why the voltage range is 12.8 to 17.6 and not just because the voltage range of the cell is only like, what's that, 0.8 volts of the cell, right? Yeah, 3.2 to 4.4 is no, it's not. It's 1.2, isn't it? So that's 1.2 volts, but the voltage range is well over 5 volts. That's because we've got the voltage of the previous cells to allow for as well, because we can't just measure across that cell. We have to measure the voltage at that point from the ground. And so this one might be right down here somewhere, so you might have a large voltage range. So we have to calculate that, and that's where it all comes in a bit funny. And we have to have a divider here. So this one is, I think, 3/4. This one's half. And I kind of stopped, I believe, because I think I'd finished it because I couldn't work out the rest of the stuff. But now I need to do that because otherwise I won't be able to work it. And this is important because this is how battery management works. This is how cell management and cell balancing works. But the other side of this, which I haven't put on this, quite a big one now, isn't it? Can't get it in picture. The other side of it that I haven't put on this is not just to do, there's the circuit, is not just to do the measurement, but also to actively balance the cells. So if you have cells which are low voltage or high voltage, then what you do then is if it's a high voltage cell, right, then you will attempt to charge the other cells to make it sort of the same. Well, actually, I don't know. The likely scenario is one cell is actually lower than the rest, right, because of something. But you have to account for one cell being higher than the rest. You don't discharge it. No, what you do basically is, as the whole pack discharges, you've got one of the cells which is a bit higher than the rest, right? But then it starts discharging. Say maybe one's at 80% and the rest are at about sort of 50% or something like that, right? And so what you do then is you then actively go around topping up the others, right? When the next charge cycle comes, you go around, or even when you're not, even when your car's just sat itself on its own, what you do then is you then actually start topping up the cells just using the whole pack as a power pack, right? So you use the whole pack as a power pack, and then you separately and individually charge the cells to bring them up to the same voltage. And of course, if you're obviously pulling power from the cells, all the cells, to charge one, right? So what you're doing is you're reducing the voltage of the others and increasing just that one. So you're doing a balancing. And so that means if you have one that's actually quite high, what happens is that they all start discharging, and if you're going around basically charging up all of the individual cells, then eventually these ones will start rising. They'll rise the charge depending on which one you're doing, and this one, because it's part of the pack which is contributing to the overall charge circuit, it will then you'll start pulling charge from all of them. So you'll be using the voltage of all of them to contribute to one. So you're transferring the charge from the whole battery to one cell, a small amount, you see. And you can go around doing all of that over time. And because if the car's sat for overnight and it's not doing anything, then it won't take much current. And you can do this through the metering wires. You just give it reasonably substantial metering wires. An amp would be enough. And then you can just trickle charge them at the rate of an amp, right, which is 3 watts. So you're pulling 3 watts from the whole pack, and you're actually using it to charge one. And that's how you can redistribute it. It's not a complicated thing to do, because all you're doing essentially is, instead of doing it from a wall outlet, you're just simply using this pack as an input voltage. That's all. And then you can go around charging. It's very simple. And so you just simply detect which ones are low and start charging them. Yeah, from the whole pack. Now, if they are not perfectly aligned in the voltage, right, that there might be one that's like 0.1 volts out, you don't go around trying to charge it, because what you're essentially doing then is you're going to be wasting power, because it's not going to be an efficient system. You're going to get an 80% an 80% loss when you're actually trying to top up one cell. So if they're pretty close, then you'll just leave it, because you're just basically you're just burning it off then. So you shouldn't do that. But if one is considerably lower, then what happens is you can't use the car, right? Because this one's going to discharge or something, and then the BMS will see that one's discharged, right? And it'll stop the charge. So you'll actually lose range because you won't be able to use the whole pack correctly. So it's better to take some power and put it into that one to bring that charge level up so they're all the same, and then you've got the full range of the car, even though you're losing 20% of a small amount of power, 3 watts. So you'd be, to do a cell balancing, you're basically not going to be, discharging your battery by 20%. No. If you lose 1%, I think that will probably be a figure you can look at, right? So